Welcome back, dear students. So let's continue with the chapter on rational and irrational numbers. So in the last class, we learned about rational numbers, isn't it? So today we are going to continue our work with irrational numbers. Okay. Now, what is irrational number? Let's see the definition from your book itself. Okay, so here I have your book. It says the square roots, cube roots, etc. of natural numbers are irrational numbers if the exact value cannot be obtained. Okay, so for example, here what the definition is trying to say is the square root or cube root. Okay, for example, you can take in square root, let me take square root of 3. Okay, and in cube root, let me take cube root of 5. Okay, now can I find the square root of 3? Do you know what is the value? For example, we know what is the square root of 4, and how much is this? It is just 2, isn't it? Similarly, square root of 9 is 3. We know their exact values, isn't it? But do you know how much is the exact value here? No, right? Okay, so similarly, cube root of 8, is how much? 2, because 2 into 2 into 2, that is 2 cube is 8, right? Similarly, cube root of 27 is 3, because 3 cube is 27, isn't it? So we know their exact value. But do you know what is the exact value of cube root of 5? Do you know this? No, right? So if you don't know the exact value, such kind of numbers are known as irrational numbers. That's what is the meaning of your first definition. Okay, so let's see the second definition. It says a non-terminating and non-recurring decimal is an irrational number. Okay, so I have already told you what is non-terminating and non-recurring, right? So non-terminating is this particular. Okay, see, this is the example given to you. So here this non-terminating, this goes on and on and on. Okay, and this is not recurring also, because although 4 is repeating here, after 4 comes 5, isn't it? Okay, so if only 4 comes, then it becomes recurring. Remember that. Okay, similarly, this is also continuing, and this is also non-recurring. Okay, non-terminating and non-recurring. So such kind of numbers are also known as irrational numbers. Okay, and the very important is the number pi. Okay, so you have come across the value of pi in specially mensuration, isn't it? So how much is the value of pi? You take this as 22/7, isn't it? Okay, so actually, the value of pi is not 22/7 exactly. This is just an approximate value. Okay, the exact value will be this much. Okay, 3.1415925. So it is continuous, right? Now this is non-terminating and non-recurring, isn't it? So that's why the value of pi is also irrational numbers. Okay, so these are the things that you need to keep in mind about irrational numbers. Okay, so let's talk about the notation of rational and irrational numbers. Okay, now this rational, okay, so we have got many rational numbers, isn't it? So if I put all the rational number within this bracket, this bracket is called sets. Okay, so if I put all the rational numbers within this bracket, this is called set of rational numbers. But every time, I don't know all the rational numbers, so every time I cannot write this way. So there is a notation for the sets of rational number, and it is denoted as q. Okay, so this symbol q represents the set of rational numbers, that is this entire set. Now in this very same set, instead of rational numbers, if I place all the irrational numbers, that is called set of irrational numbers. Okay, so set of irrational numbers is denoted by Q bar. Okay, so Q stands for set of rational numbers, and Q bar represents set of irrational numbers. Okay, now let's talk about something called real numbers. Okay, now you must be knowing that real numbers are denoted by letter R. Okay, so not real numbers, it is set of real numbers. Okay, so set of real numbers is denoted by R. Now you know this R, that is set of real numbers, is a combination. Okay, is the combination of set of rational numbers, okay, and set of irrational numbers. So combination means you have to use this notation, which is called union. Okay, so union means combining rational and irrational. So when you combine all the rational and irrational numbers, you get real numbers. Okay, so that's what is the meaning of this particular thing. Okay, now let's take few problems on very concept that we have learned till now. So let's take question number 3 from exercise 1b. Okay, so let's see first in these questions, the easy ones. Okay, now 2 by 7 is an irrational number. Is this true or false? Obviously this is a fraction, means this has to be a rational number, isn't it? So this statement is false. Okay, we have 5 by 11 is a rational number. Obviously this is true. Okay, next is all rational numbers are real numbers. I told you real numbers are formed by the combination of rational and irrational. So that means, can I call all the rational numbers to be real numbers? Yes. Okay, so this is also true. Okay, now next is all real numbers are rational number. Is it true? No, because in real numbers we have irrational numbers also, remember. So that's why all real numbers cannot be considered to be rational numbers. So we will call it to be false. Okay, now some real numbers are rational numbers. Is this true? Yes, because you know all real numbers are not rational numbers. Okay, so that's why only some of the real numbers are rational numbers. So that's why this is true in our case. Okay, now let's have a look at the first question. Now remember, whenever there is a plus sign between two irrational numbers, you cannot add the numbers within the square root sign. So that means 2 plus 3 gives us 5, you know that, but root over 2 plus root over 3 will not be equals to root over 5. Remember this. Okay, so it is always false. Now next is this one. So let's see whether this is true or not. So let me do it here only. Okay, so this is my rough part. Okay, so you know what is root 4? Root 4 is 2, isn't it? Square root of 4 is 2. So there is no sign here. So that's why I have written into. So we have plus 2. So 2 into 2, 4. 4 plus 2 is 6. That means, is this true? Yes, this is true. Okay, now 3 root 7 minus 2 root 7 is root 7. Okay, so if you call root 7 to be x, then this becomes 3x minus 2 root 7 is x, right? And 3x minus 2x is just x, isn't it? And you know what is the value of x? X is root 7, isn't it? So it is root 7. So that's why this is also true. Okay, so 3 root 7 minus 2 root 7 is root 7. Okay, so let me remove this part. Okay, so I have finished question number 3 for you. Was it pretty simple? Yes. Now very important thing that you need to know. Question says, write a pair of irrational numbers whose sum is irrational. Okay, so you have to write two rational numbers whose sum is going to be irrational number. Okay, so before we do this, I would like to say a few more things here. You know, in case of rational numbers, I told you that sum of some division, product and quotient of two rational numbers will always be rational numbers, isn't it? But in case of irrational number, that may not hold good. Okay, sometimes, you know, the product of two irrational numbers can be rational also. Sum of two irrational numbers can be rational also. It can be irrational, it can be rational. Okay, so that's what happens in case of irrational numbers. Okay, but always remember, so first thing is, if you add a rational to an irrational, your result will always be irrational. Okay, similarly, if you find the difference between rational and irrational, it will be irrational. Okay, difference will also be same, multiplication will also be same, and division will also be same. That is, if you find the multiple product of rational and irrational, it will be irrational. Okay, and one more thing, there is an irrational number. Okay, so let's say root 3. Okay, so if you find it's negative, it will be negative minus of root 3. Okay, so this is the positive number, this is a negative number, both are irrational. Okay, so both are going to be irrational. That means if you change the sign, then also your irrational number will remain irrational number. Okay, so with this much of basic, let's see these problems. Okay, now question number 7 says, write a pair of irrational numbers whose sum is irrational. This is very simple. So you just give two irrational numbers, let's say root 3 and root 7. So when you add root 3 and root 7, okay, root 3 is irrational, root 7 is also irrational. Okay, now what will be their sum? It will be root 3 plus root 7, right? Now do you know what is their exact value? No, right? So that's why this also becomes irrational. Okay, now here question is asking you to find a pair of irrational numbers whose sum is going to be a rational number. So let's say 3 plus root 2. Now tell me whether this is rational or irrational. This is obviously irrational. You know why? Because we have rational plus irrational is always irrational. So this is rational plus this is irrational. So this is one irrational number. Let me take another irrational number to be 1 minus root 2. Rational minus irrational will also be irrational. Okay, now if you add these two, let's see how much do we get. So we get 3 plus root 2 plus another number is 1 minus root 2. Okay, so when you open the bracket, so what happens is 3 plus root 2 plus 1 minus root 2. So root 2 and root 2 plus and minus gets cancelled. So we get 3 plus 1, which is 4. Now see, when you add this irrational with this irrational, when you add these two irrational number, you are getting a rational number. So the required pairs are this one and this one. Okay, so you need not write this part. I have just shown you the calculation here. Isn't it very simple? Okay, now similarly write a pair of irrational number whose difference is a irrational number. You can take root 7 and root 3 again. Okay, because root 7 minus root 3 is also going to be irrational number because you don't know their exact value. Okay, now in this case you have to write a pair of irrational numbers whose difference is going to be a rational number. So you can take the same thing. So we will reverse the sign this time. Okay, so let me write this as root 2 minus 1. Okay, now if you find the difference, what happens is root 2 and root 2 gets cancelled, again you get 4. Okay, so find the difference by yourself. So these are the pairs. Okay, so let's see question number 11 now. Write a pair of irrational numbers whose product is irrational. Okay, now you have to form two irrational numbers whose product is going to be irrational. So let's see the numbers. So let me take the numbers to be root 3 and root 27. Okay, now find their product. You'll come to know that the result will be irrational. Remember, when you find the product, you remember in case of addition you cannot take the numbers within the square root. That means you cannot add the number within the square root. But in case of multiplication, okay, let me show you by myself only. So root 3 into root 27. So let's find the product. So in case of product, you can combine the square root. So you can write one square root. So you can write this as 3 into 27. Remember, we cannot write this, if there is plus, you can write square root of 3 plus 2, 27. Okay, fine. So when you multiply this two, let's say how much do we get? So 3 into 27 is 81. So square root of 81 is how much? It is 9. See? Okay, I'm sorry. This is irrational, right? Okay, so make it rational. So if you write rational, this becomes question number 12. Okay, now these are the pairs of irrational numbers whose product is going to be a rational number. Okay, similarly, if I ask you, give me a pair of irrational numbers whose product is irrational, then you can give your answer to be root 3 and root 7. Because when you multiply root 3 into root 7, you get root 21, which is also irrational. Okay, fine. So you may pause the video and note down your solution till here. And with this, we close for the day. Thank you very much.